Okay, so what we're going to look at today is balance and equations. So when you balance, you write down everything that you're given. Okay, so this is what I did right here on both the reactant side and the product side. Now, write down what you have. So you have 2, 1, 2. Oops, I forgot there's 4 of these. And then you've got 1 oxygen. Okay, on this side, you've got 8, 4, 4. Oops, there's 9 hydrogen. Sorry, I left out that one. And 1 Cl. So what you want to start doing is looking at how you can balance these. So let's first start with, I'm going to leave the hydrogens because they're odd. Let's start with the Si. So I've got 4 on this side and I've only got 1 here. So the very first thing I would do is put a 4 here. When I put a 4 there, that's going to change this to 8, 9, 10. That's going to change the Si to 4 and the chlorine to 4. So now let's look at another one that I can do. All right, I need 4 oxygen over here. Well, what if I put a 4 right here? If I do that, that now gives me 8 and 8, so I have 16 hydrogen. Okay, I've got, my silicon didn't change, but I've got 4 oxygen. All right, so notice that right now everything is okay except my hydrogens and my chlorines. So the next thing I would do is, what could I put on this side to help balance this? Well, if I need 16 and I've already got 8, if I put an 8 right here, that's going to give me 16 hydrogens. Notice that it gives me 8 Cls, and I forgot to change that. That's 8 over there, so I am balanced. Okay? All right. Let's look at predicting. I want to talk about predicting, solubility rules, and things like when we're having to look at that chart. Whenever you're predicting products, you've got to use this here that's in your reference table. That lets you know, like for those carbonates that are right here, that lets you know for the metal oxides and waters how to react those. All right, so let's look at solubility rules. I want to know if AgCl is soluble. Well, if you look down here, chlorides are soluble unless they have silver, lead, or mercury. So this is going to be insoluble. All right, the next thing, let's look at Na2S. Well, S is a sulfide. Notice that sulfides are on the side that are insoluble, but all sulfides are soluble if they have a group 1. So this would make that soluble. So whenever you're doing solubility, you've got to look at these soluble rules and remember your exceptions. So let's predict. So first of all, I've got magnesium chloride plus calcium. So can calcium replace magnesium? If you go back to here, this is magnesium, here's calcium. The one you're trying to replace has to be higher, okay? So calcium is higher than magnesium, so it can replace it. So this would be CaCl2 plus Mg, okay? And if I wanted to, notice that it's already balanced. I don't even have to go about balancing it. All right, if it's a double replacement, this is going to go here, and this is going to go here. And then you've got to determine if the two things are soluble or not soluble. If they're both soluble, then the reaction's not going to take place. So I've got SrSO4 plus LiNO3. All right, all nitrates are soluble, so that is aqueous. Okay, if I've got SrSO4, I'm going to go back to my solubility rules. Sulfates are soluble unless they have strontium. So this is going to make this a solid, so this reaction is going to take place. That's how we predict products. The last thing that's going to be on these tests is your stoichiometry. So with stoichiometry, you got to remember, first make sure your equation's balanced. And if you notice that I did balance your equation already. So you write down always what you're given. So 10 grams of zinc, okay? If I'm in grams, I've got to get to moles. So you're looking at 1 mole of zinc equals 65 grams of zinc. Okay, now I can do my mole ratio off of this balanced equation. My want is this 1 mole of zinc chloride. My given was zinc. There's 1 mole of zinc. Now, this is where everybody tends to get confused. Notice that it wants it in molecules. So in order to convert to molecules, I'm going to multiply it by 6.02 times 10 to the 23rd over 1 mole of zinc chloride. See how all of these cancel? And I'm left with molecules. And when you multiply all this out, you should get 9.26 times 10 to the 15th. Make sure I've got that right. Oh, no. Sorry. I wrote down the wrong thing. You should get 9.26 times 10 to the 22nd. Okay? All right. The last thing was a percent yield problem. Here's how you know if you've got a percent yield. If you've got 2 different values, then you know you're not just doing a stoichiometry problem. The very first one is what we do when we do just theoretical yield. So the first thing I want to do is I'm going to use what I'm given, 7 grams of calcium hydroxide. Go ahead and convert that to moles. So 1 mole over 74 grams. Okay. I want my wants and givens. I'm looking for silver hydroxide. So 2 moles of AgOH over 1 mole of CaOH2. And I'm looking for it in grams because notice that silver hydroxide is in grams. So that's 125. And when I multiply all that out, I get 23.64 grams. This is my theoretical yield. Now I'm going to use this, which is my actual yield. So I'm going to say 19.9 divided by 23.64 times 100. And when I do that, I'm going to get 84.17%. That is my percent yield. So the difference between a percent yield problem and a normal stoichiometry, notice how we only have 1, and here we have 2. The next thing, how do you know which one to use? This right here is attached to the word produced or made. That's how you know you don't use that until the very end. So I have gone over everything that we're going to have on your test. Solubility, predicting products, stoichiometry, and percent yield.